Europe builds the world's finest cars, the fastest trains, some of the most advanced ships on the planet. So why, when it comes to outboard motors, did an entire continent hand the market over to Wisconsin and Japan? Walk into any marina from Miami to Melbourne, and you'll see the same names on every boat. Mercury, Yamaha, Suzuki. But cross the Atlantic, and everything changes. Different engines, different fuel, a completely different idea of what power should be. This isn't just about motors. It's about two worlds that looked at the same ocean and saw two different problems to solve. Now I have a question for you. If you had to choose between raw horsepower and maximum efficiency, which side would you be on? Drop your answer in the comments. And if you want to understand the hidden forces that shaped the engines on your boat, hit subscribe and stick around. Because by the end of this video, you'll never look at your outboard the same way again. To understand why these two markets diverged so dramatically, you have to go back to the beginning. Not to the factories, but to the water itself. In the United States, the geography wrote the rules. Vast freshwater lakes stretching beyond the horizon. Coastal fisheries spanning thousands of miles. Wide-open waterways where speed wasn't just a luxury. It was the whole point. American boating culture grew up around the idea of escape. The weekend trip to the lake, the fishing tournament at dawn, water skiing with the family on a hot July afternoon. And all of it demanded one thing above everything else: power. By the 1990s, Mercury Marine alone controlled more than 40% of the North American outboard market. The average horsepower on American transoms climbed from 75 in 1985 to well over 200 by 2020, and none of this would have been possible without one critical advantage: cheap fuel. For decades, American gasoline hovered under $2 a gallon. Horsepower was practically free. Now cross the Atlantic, and the picture changes completely. European waterways tell a different story. Narrow canals, protected Mediterranean bays, coastal cruising with frequent port stops rather than long open water runs. And here, boating wasn't just recreation, it was transportation, commercial fishing fleets, charter operations running 12 months a year. Boats that had to earn their keep, not just provide weekend thrills. But the biggest difference wasn't geography, it was economics. European fuel prices have historically run 2 to 3 times higher than American prices, driven by heavy taxation. A boat owner in Germany or the United Kingdom couldn't afford to burn 25 gallons an hour chasing top speed. Every drop of fuel was a business decision. So while Americans optimized for power, Europeans optimized for efficiency. And for decades, these two philosophies coexisted peacefully, separated by an ocean, each succeeding on its own terms, and completely unaware that forces were building that would eventually pit them against each other. For a long time, the American approach and the European approach existed in parallel. Two separate worlds, solving two separate problems. But in the late 20th century, a new force entered the equation. And it didn't care about tradition, regulation. In the United States, the Environmental Protection Agency focused its attention on hydrocarbon and nitrogen oxide emissions, the chemicals most associated with smog and air quality. Gasoline outboards adapted. Catalytic converter technology, borrowed from the automotive industry, helped American engines meet the new standards without fundamentally changing their design. High horsepower survived. But in Europe, regulators saw the problem differently. The European Union didn't just target tailpipe emissions. It went after noise pollution, carbon dioxide output, and overall fuel efficiency. And under those rules, diesel engines held a quiet advantage. Yes, diesel produced particulates, but it also burned less fuel per mile traveled. A 300 horsepower gasoline outboard consumes roughly 25 gallons per hour at full throttle. A comparable diesel inboard or stern drive uses 12 to 15, nearly half. For European commercial operators running 1,000 hours a year, the math was unavoidable. Diesel meant survival, but here's where the story takes an unexpected turn. If diesel was so advantageous in Europe, Why didn't European manufacturers simply build diesel outboards and dominate the global market? The answer is engineering. Diesel engines require compression ignition, which demands heavier, stronger engine blocks. Packaging that weight and complexity into a compact outboard housing, something you can hang off the back of a boat, presented challenges that no major manufacturer was willing to prioritize. The market was too small, the investment too large. So European boaters adapted. They turned to inboards and stern drives from Volvo Penta, Yanmar, and Nani. They abandoned the outboard form factor altogether. And in doing so, they handed the outboard market to the Americans and the Japanese almost by default. One European dealer put it simply: customers asked for diesel outboards for years. The answer was always the same: they don't exist. Not at the power levels you need, so people bought stern drives instead. The market didn't change. It worked around a gap that no one filled. For decades, American and Japanese outboard manufacturers looked across the Atlantic and saw opportunity. Millions of boaters, growing economies, a market waiting to be conquered. But when Mercury and Yamaha pushed into Europe with their high-horsepower gasoline flagships, they discovered something unexpected: resistance. European commercial operators didn't want 400-horsepower gasoline engines. They wanted fuel economy. Charter companies didn't care about top speed. They cared about cost per nautical mile. Even when American manufacturers offered competitive pricing, cultural skepticism slowed adoption. The Verado line, Mercury's technological masterpiece, struggled to gain traction in Mediterranean markets despite its engineering sophistication. It was a product designed for American expectations, meeting buyers who measured success by completely different standards. But Europe wasn't content to simply reject the American approach. It began building an alternative. In 2007, a small British company called Cox Marine set out to do what the giants refused to attempt: build a true high-horsepower diesel outboard. 13 years later, in 2020, they delivered the CXO 300, 300-horsepower compression ignition, designed from the ground up for the back of a boat. The price tag exceeded $90,000 per unit, more than double a comparable gasoline outboard. But Cox wasn't chasing weekend fishermen. They targeted coast guards, military operators, and professional fleets who measured value in fuel burned over thousands of hours, not sticker price at the dealership. And Cox wasn't alone. While the diesel outboard solved one problem, another European company was betting on a different future entirely. Torqeedo, founded in Germany in 2005, became the global leader in electric outboard propulsion. European regulations, emission zones in harbors, strict noise limits in residential waterways created demand that American markets hadn't yet developed. By 2023, electric outboard adoption in Europe was outpacing the United States by nearly 3-to-1. Europe didn't win the gasoline horsepower war, but perhaps it was never trying to. While American manufacturers perfected one technology, European innovators were quietly building alternatives for a world that might not run on gasoline forever. So why did two of the world's most advanced industrial regions end up building such different machines for the same purpose? The answer isn't engineering capability. Both sides have brilliant engineers, world-class manufacturing, and decades of marine expertise. The difference is something more fundamental. Each market was forced to optimize for a different problem. In America, fuel was cheap and water was open. The logical choice was power. Big engines that could move heavy boats fast across long distances. Regulations focused on emissions that affected air quality, and gasoline technology adapted to meet those standards. The market rewarded horsepower, and manufacturers delivered. In Europe, fuel was expensive and waterways were constrained. The logical choice was efficiency. Engines that could run all day without bankrupting their operators. Regulations targeted carbon output and noise, pushing the market toward diesel inboards and, eventually, electric alternatives. the outboard form factor became secondary to the economics of operation. Neither approach is wrong. Each market solved its own problem with the tools and constraints it had available. But here's what many observers miss. These differences weren't permanent. They were stable until the conditions that created them began to shift. Today, American fuel prices are climbing. European emission zones are tightening. Global shipping regulations from the International Maritime Organization are pushing all vessels toward cleaner propulsion by 2030 and beyond. The forces that once kept these markets separate are slowly converging. American manufacturers are investing heavily in electric technology. Mercury's Avator series represents a serious commitment to battery-powered propulsion. Meanwhile, European diesel expertise may become increasingly valuable as hybrid systems emerge. Combining electric motors for harbor operation with diesel generators for extended range, the question is no longer whether these two philosophies will meet. The question is what happens when they do. Will one approach dominate? Will they merge into something new? Or will regional differences persist even as the technology evolves? The next decade will provide the answer. And the companies that read the future correctly will inherit the market. The marine industry stands at a crossroads. For a century, the Atlantic Ocean didn't just separate two continents, it separated two philosophies of propulsion, two ideas of what an outboard motor should be. And now, for the first time, those ideas are being forced into the same conversation. The forces pushing toward convergence are powerful. Global emissions targets are tightening. The International Maritime Organization's 2030 and 2050 goals will pressure every segment of the marine market toward cleaner alternatives. Electric propulsion is advancing rapidly, with battery density improving and charging infrastructure slowly expanding. Hybrid systems, combining electric motors for quiet harbor operation with combustion engines for range, are emerging as a bridge technology that draws on both American horsepower and European efficiency. But the forces maintaining the divide are equally stubborn. Infrastructure remains a fundamental barrier. American marinas weren't built to charge hundreds of electric boats overnight. European commercial operators can't simply abandon diesel fleets that have decades of service life remaining. And cultural inertia runs deep. American boaters still want speed and power. European operators still want economy and endurance. These preferences don't change with a regulation or a product launch. Perhaps the most honest prediction is this: convergence will happen, but it will happen slowly and unevenly. Some segments, small recreational boats, marina tenders, protected waterway operations, will electrify quickly. Others, offshore fishing, long-range cruising, commercial workboats, will resist until the technology matures further. And regional differences may persist for decades, even as the underlying propulsion systems evolve. What remains certain is that the engines of the future will be shaped by the same forces that shaped the engines of the past: geography, economics, regulation, and the quiet preferences of the people who depend on them. Engineering doesn't happen in a vacuum. It happens in a world of fuel prices, government rules, and the daily demands of life on the water. The outboards on your transom weren't just designed. They were shaped by forces most boaters never see. And understanding those forces is the first step to understanding what comes next.